Hi everyone, my name is Stephen Wegulo and my presentation for this year's wheat disease in service will focus on managing mite transmitted viruses of wheat in the Great Plains. And this is because in 2025, the most damaging disease in Nebraska wheat fields was the wheat streak mosaic disease complex. So my presentation is in two parts. Part one would be just general introduction on mite transmitted viruses of wheat. And then the second part will be on management of mite transmitted viruses of wheat. So there are three mite transmitted viruses of wheat, and the mite itself is called the wheat caul mite. It's a tiny microscopic mite, about 1/100th of an inch in size. So you need a magnifier to see it, or you can look at it through the microscope. So these three viruses are wheat streak mosaic virus, High Plains wheat mosaic virus, and Twitcam mosaic virus. So the symptoms are indistinguishable. You cannot tell which virus is which by just looking at the symptoms. You have to do a lab test such as ELISA or PCR in order to determine which particular virus you are looking at. So just some background on these three viruses. Wheat streak mosaic virus was first described in Nebraska in 1922 as yellow mosaic, but the name wheat streak mosaic was not assigned until the 1950s, when it was also confirmed at that time that the wheat caul mite was the vector of this virus. And then High Plains wheat mosaic virus was discovered in 1993 in the Great Plains, in several states in the Great Plains, Nebraska, Kansas, South Dakota, etc. And so it was discovered in 1993, infecting both wheat and corn. And then Twitcam mosaic is the one that is the latest one to be discovered. It was discovered in Kansas in 2006. And so all three viruses can be transmitted only by the wheat caul mite. Here is a field of wheat in 2017 when we had widespread epidemics of wheat streak mosaic. It's a disease complex, but I would just refer to it as wheat streak mosaic. When I say that, it refers to the disease complex of three viruses. So in 2017, we had widespread epidemics actually throughout the Great Plains, and they were particularly severe here in Nebraska and Kansas. This is a field in Duo County in the southern panhandle of Nebraska, and you can see that it is completely destroyed by this disease complex. And just this year in 2025, we had widespread occurrence of this disease complex, but it varied from very mild symptoms or just a plant here and there to total loss, like in this field you're looking at in Kearney County. This was on May 7th of 2025. So you can see, again, this is a 100% loss of this field from the disease complex. So the symptoms are usually a mosaic of pale green and yellow streaks, as you can see in the top of this slide, on young leaves. And then this yellowing intensifies as temperatures rise in the spring. The plants get stunted. And then we also have what we call spraddled growth or prostrate growth, like you can see in the bottom picture there, where the tillers grow sideways instead of upright. And then the heads may be, the heads may not feel grain, or they may be poorly filled with grain, and the kernels will be shriveled. This slide is a good summary of the disease cycle, or part of the disease cycle. I'll explain the whole of it, showing this disease complex throughout the year. So on the left, here on the, this is, we are calling this the old crop. So this is in June. This wheat was planted in the fall of the previous year. Then it went through dormancy. Then it started growing in the spring, and then it's headed in June. And in any wheat field, a large wheat field, you will normally see literally hundreds of, or actually millions or billions of mites in a wheat field. The mites are tiny, they are very susceptible to drying, therefore they like protected spaces on the wheat plant. And the heads have these little spaces where the mites are protected from desiccation. So you can see, so this is in June, and you can see this cloud of mites. They are just a lot of them in the field, and they may or may not be carrying virus, any of the three viruses or all of the viruses. If just before harvest, a hailstorm comes through and shatters this grain that is mature enough to germinate, the grain will germinate into volunteer wheat. We call it volunteer wheat, as you can see here. And this volunteer wheat will grow throughout the summer into the fall. I have to mention that the most favored host for the wheat kern mite is wheat. There are other grassy hosts, but they're not as favorable to the mite as wheat. So if this volunteer grows throughout the summer into the fall, and the mite populations build on it to very high levels, and then in the fall, after wheat, the new wheat plant, wheat crop has emerged in the fall, the mites are blown onto it. They cannot move by themselves. They have to be picked up and blown around by wind. So the mites are blown onto the newly emerged wheat in the fall. They transmit the viruses, and then in the winter, the mites will overwinter in the crown of the wheat plants as nymphs or as adults, whereas the viruses will overwinter in the live tissues of the wheat plant until spring the following year, when temperatures warm up. The mites become active, and they're blown around again, and they continue spreading the viruses. So so this picture shows just a snapshot of the life cycle of this disease complex from the fall, from the spring during growth to after harvest, and into the fall, and then back into the spring. So here, the amount of damage caused by the viruses, it varies with the time of infection. So if we have infections occurring early in the fall, just after the wheat crop has emerged, at the seedling or early tillering growth stage, then the damage is usually very severe. We end up with severe stunting, that spraddling growth that I showed, and then yellowing. And usually when this happens, early infections in the fall, we are looking at some very drastic yield loss, like in those two fields I showed you, pretty much 100% yield loss. If the infections occur in late fall or early spring at the tillering growth stage, we will have some yellowing, but growth will be mostly upright, only minor stunting. And then the yield loss will be low to moderate. And infections can also occur in spring at the jointing through heading growth stages. During those late growth stages, the symptoms are not very conspicuous. They are limited to just leaf yellowing, and usually there will be little or no yield loss. So in 2010 and 2011, we did some surveys of wheat fields for these viruses in 4 states, Kansas, Nebraska, South Dakota, and Colorado. And we collected symptomatic wheat plants from the fields, both in the spring and in the fall. Here I'm showing only the spring 2011 as an example. And the different colors show different viruses and their combinations. So yellow shows wheat streak mosaic virus only, and you see it was the predominant one in both surveys. Actually, we did 4 surveys, spring 2010, fall 2010, spring 2011, fall 2011. And in all 4 surveys, the predominant virus was wheat streak mosaic virus. Then we also had High Plains virus, and then also we had Triticum mosaic virus. The brown is Triticum mosaic virus, and the purple is High Plains virus, and then combinations of those viruses. So, for example, red shows counties where we found all 3 viruses, or samples that we tested for all 3 viruses. So the point here is that these viruses are widespread in the Great Plains states of the United States. And so from this survey, we counted the percentage of viruses that occurred just by itself, or as 2 viruses, double infection or triple infection. And this table shows that wheat streak mosaic virus and High Plains wheat mosaic virus mostly occurred by themselves as single infections, whereas Triticum mosaic virus occurred mostly as a double infection, and mostly as a double infection with the wheat streak mosaic virus. The triple infections were there, but they were very low in incidence. And I will show you in a slide that is upcoming. When you have these triple infections, the damage is just devastating. That's when you really end up with those 100% losses. So let's now move to the second part, which is management of mite-transmitted viruses of wheat. This slide shows the risk factors for this disease complex. The highest risk for the wheat streak mosaic virus disease complex is pre-harvest volunteer wheat emerging in wheat fields following a hailstorm. I showed you already in that graphic. If a hailstorm comes in just before harvest, it shatters the grain germinates into volunteer wheat. That volunteer is not controlled, it continues to grow into the fall. The mite populations build on that volunteer. The viruses also increase in that volunteer, and then the mites will transmit the viruses to the newly emerged wheat in the fall. That's the highest risk for this disease complex. Then cereal crops and grassy weeds growing until wheat planting. So these viruses also infect several other cereal crops apart from wheat. For example, maize or corn, foxtail millet, and so forth. So if you have these cereal crops growing, they're still green when the wheat in the fall emerges, then that's a risk. The mites will move from them and move on to the newly emerged wheat and transmit the viruses. Then cool, wet summers, they favor growth of volunteer wheat and other hosts of wheat kernel mites and the viruses. Then if we have a prolonged warm fall, that's also very favorable to high risk for this disease complex. Early planting of wheat gives more time for the mites to infest the wheat and to transmit the viruses, and also more times, a longer time for the viruses to replicate or multiply within the wheat crop and cause more severe damage. And then planting wheat next to late maturing hosts, as I mentioned, that are hosts to the mites and the viruses, that's also a risk. So you want to avoid planting next to late maturing corn or millet. So, so the first control measure or management measure is control volunteer wheat before planting in the fall. All volunteer wheat must be completely dead at least 2 weeks before planting in the fall. And the highest risk is the volunteer that grows, that emerges before wheat harvest, because at that time, once the wheat dries down, the mites must find a green host to survive on. So if this volunteer emerges before harvest, the mites will move from the drying out wheat and on to infest this volunteer very heavily. And so the risk will be very high if there is volunteer that emerged before wheat harvest. And then the volunteer that is in summer crops, for example, sunflower, that one is also a high risk for this virus complex. And then number 2, control post-harvest grassy weeds. So there are several species of grassy weeds that are hosts to both the mites and the viruses. They are not very good hosts like wheat, but they are hosts and they can be a reservoir. So the risk level for these grassy weeds is low, but it increases the longer the time they are allowed to grow. So if you have these post-harvest grass weeds in the field, you want to make sure that they are controlled. And then number 3, plant resistant or tolerant varieties. So here I'm showing research plots. This was part of the same project that we did in 2010 and 2011, actually through 2012. And so here we are showing on the right maize, which was it's a resistant variety developed by Dr. Bob Graybosch. Before he retired, he was a USDA scientist based here in Lincoln. He developed this maize variety with the resistant gene WSM1 to wheat streak mosaic. It was specifically targeting wheat streak mosaic. So we inoculated these plots with triticum by itself, wheat streak mosaic virus by itself, and then a combination of them. So here I'm showing on the left just maize, the resistant variety, inoculated with both viruses, and you can see this is April 11, 2011. You can see the resistance is really holding, whereas the susceptible, Millennium is susceptible, and we also inoculated it with both viruses showing here. You can see the yellowing in April is pretty significant. And then just about 7 years later, the same plots, you can see the resistance in maize is still holding very well, whereas Millennium is completely destroyed within just about 7 weeks. So resistance can really help with managing these viruses. And from those plots, I'm showing here a slide of yield. And you can see, so again, this on the y-axis yield in bushels per acre, and then on the x-axis are the viruses that we inoculated with. So then the black bars represent yield of maize. You can see that it's very stable regardless of the inoculation, whether it's double inoculation or a single inoculation or not inoculated. Maize is very stable in the yield. Then the the gray bars represent Millennium, the susceptible one, and you can see where we inoculated with a single virus, very significant reduction in yield compared to the where we did not inoculate on the right here. And where we inoculated with both viruses, the crop was completely destroyed. Here is showing about 3 bushels per acre of yield in the susceptible Millennium inoculated with both Tutica mosaic and with Tutica mosaic. Now, on the non-inoculated, you can see that the yield in Millennium, which is susceptible, is actually significantly higher than in maize. And this highlights the point that maize, when they introduced this gene into it for resistance to its mosaic, that gene WSM1 had a yield drag on maize. And so because of the gene, maize did not yield very well. And it was grown for a number of years, but it didn't do very well because of the yield drag that gene introduced in it. So in the absence of disease or in the absence of the viruses, you can see that Millennium, the susceptible one, yields very well compared to maize. And so Dr. Gary Hein, he retired last year, I believe. He was based at the Panhandle Research Extension Center and Education Center in Scottsbluff for many years, I believe over 20 years, where he carried out, every year he carried out this screen with breeders where they put in different wheat varieties or lines from breeders, from private companies. You see, he did this screen throughout his career at UNL. And when he moved east here in Lincoln, he continued with it until he retired. But this is one of his screens, and you can see that there are some lines that are showing very good resistance. So he inoculated this. He plants a susceptible variety around, it grows through the summer, and then the mites build on it, and then in the fall he plants, and then that serves as the source of inoculum. And you can see that the following spring, this is what you see. Some lines are very susceptible, others have very good resistance. And again, this is part of his screen as well, showing the different varieties here. You can see here maize standing very well. Snomas is another one that has another gene. I think it's WSM2. Maize has WSM1. And then these other ones, Pronghorn, Millennium, Wesley, you can see very susceptible. Then there are another good ones here, Term 112 and Term 12 for Oakley and Clara. These ones are also, they have some of those genes for resistance to wheat mosaic. Another screen of Gary Hein here, again showing maize here standing very well. And then Term 12 for Oakley, the ones with the resistance genes, they are standing out quite well. The susceptible ones, you can see a lot of yellowing in them. Then the fourth management strategy is to avoid early planting of winter wheat. And as I mentioned, if you plant early, you give more time for the mites to infest the newly emerged wheat and they transmit the viruses. And then it gives also more time for the viruses to replicate or multiply within the wheat plant and cause a lot of damage. So this one is showing the variety maize planted at three planting dates. Planting date 1 is early, I believe it was in late August, and this, I believe this is in the Panhandle, southern Panhandle at the High Plains Ag Lab. I believe that's where this research was done. But you can see the early planted maize, even though it has resistance, still it was affected because of that long time that it was exposed to the mites and the viruses. And the late planting date here would have been probably in September, maybe mid-September or late September. You see the damage is less in the late planted wheat. This is Nomas also has some good resistance, and the pattern is very similar to that of maize, which is also resistant. The earlier planted wheat is showing more damage just because the wheat was exposed longer to the mites and the viruses than the late planted wheat. And this is Pronghong, which is susceptible, and you can see the early planted one, it was completely destroyed, and even the late planted one, it looks a little good, but still a lot of damage to it. So avoid early planting of winter wheat. We usually recommend planting at the recommended date for each region in the state. And then number 5, avoid mite virus host crops growing after wheat emergence. Here I'm showing a wheat field, a newly emerged wheat next to a cornfield that has already been harvested. So when you have this, the risk is quite low compared to if you have this situation where you see the corn is still green, the wheat has emerged. This is a high risk because the mites will move off of the corn and transmit the viruses onto the wheat. And so you want to avoid those kinds of situations. So just to summarize on the management, control green bridge hosts. Those are the hosts like volunteer wheat and grassy weeds that grow throughout the summer from harvest to planting. And so they act as a bridge, a green bridge, to carry the mites and viruses from harvesting to the newly emerged wheat in the fall. So control those green bridge hosts. They must be completely dead at least 2 weeks, 14 days before planting in the fall. Plant varieties that have good resistance. There aren't a lot of them, but there are quite a good number of varieties now that have good resistance to the disease complex. You have to be aware that those genes, we now have 3 of them, WSM1, WSM2, and WSM3. 3 hasn't been introgressed much into wheat, but WSM1 and WSM2 have. Those genes, some of them target just one virus. So for example, WSM1 targets wheat streak mosaic virus, and it will not have an effect on triticum. So you might plant a wheat variety thinking it's resistant, but it shows symptoms. That means the gene it has may not be effective on all 3 viruses, especially wheat streak and triticum. Those are the most widespread or common. High plains is there, but it's not as widespread as the other 2 viruses. Avoid early planting of winter wheat. Plant high-risk fields last. These are the fields next to late maturing crops and grassy weeds that are hosts to the viruses and wheat mite hosts, vectors. Avoid planting wheat next to high-risk fields and avoid late planting of spring wheat. For spring wheat, the earlier you plant, the better, because the temperatures are still a little cooler and the mites are not as actively being blown around as if temperatures have warmed up later in the spring. So for spring wheat, avoid planting late, plant it early in the spring. For winter wheat, avoid planting it early, plant it later in the fall. And here, this last slide has some resources, mainly just videos. They were put together with the Gary Hines leadership, and so you can watch these. They are available on the web.